Assalamualaikum everyone. I hope you all are doing well. This is your instructor Ali Faruqi and you are watching Science with Ali. So in our last class, we started our discussion on redox reactions. So we defined redox, which is a term made by joining red and ox together, where these are two processes that take place simultaneously, that always happen simultaneously. We also discussed some types of oxidation and reduction with the help of this table, in which we discussed that gain of oxygen, loss of electron, loss of hydrogen, and increase in oxidation states / oxidation numbers are all oxidations. And in terms of reduction, we discussed the loss of electrons, gain of electrons, and loss of oxygen, gain of electrons and gain of hydrogen and the decrease in oxidation number is the reduction. So in the last class, we also the last class, our main topic was gain of oxygen and the loss of hydrogen, as well as these two as well. So we are going to do a quick recap of our first class, in which we discussed this example in terms of oxygen. So as we can clearly see over here, that zinc plus copper oxide gives us zinc oxide and copper. So we can clearly see that zinc has gained oxygen, so it was oxidized, and the copper was lost the oxygen, so it was reduced. As well as the second example, we moved on, in which we discussed that Fe2O3 loses the oxygen, so it is reduced, and the carbon monoxide gains the oxygen, so it is oxidized. So the second part, which was in terms of hydrogen, we did that reduction is gain of hydrogen and oxidation is loss of hydrogen. So we did this as well, in which NH3 lost the hydrogen to become oxidized, and the Br2 gained the hydrogen to become reduced. So having said all this, the third point that defines oxidation and reduction is in terms of electrons. So reduction, let me change my pen color. So reduction is gain of electrons, and oxidation is the loss of electrons. So our first equation that we have is 2Na plus Cl2 gives us 2NaCl. So let's look at a few examples and try to understand what we are talking about here. Before we understand what's exactly happening in terms of gain and loss of electrons, we need to discuss a few things. So if you look at your periodic table, you can see that sodium belongs to group number 1 and chlorine belongs to group number 7. So we can see that all group 1 contains metals, so sodium is a metal, and group 7 are all non-metals, so chlorine is a non-metal, right? So we all know that all metals because they belong in group 1, they will have to lose one electron. We will have to lose one electron to become stable. So let's write that over here. Lose one electron to become stable. Let me just paint this in red. And as for chlorine, we will see that they will gain one electron to become stable. So we can clearly now see that sodium is unbonded as a reactant and chlorine is also unbonded as a reactant. So sodium is obviously making an ionic bond with chlorine, which refers to the fact that sodium has undergone loss of electron to become stable, because metals need to lose to make a bond. Metals need to lose one electron to become stable. So we can say that sodium is undergoing loss of electron. Sodium is undergoing loss of electron, and on the other hand chlorine is gaining an electron, so it is undergoing gaining electron, right? So as I've written over here, that reduction is the gain of electrons and oxidation is the loss of electrons. So because sodium is losing the electron, we can say that sodium is being oxidized and chlorine is being reduced. I will repeat this one more time for more clarity. So because sodium belongs to group 1 of the periodic table, we have to make a conclusion. We know this conclusion that sodium will lose one electron to become stable because it's a metal. And on the other hand, because chlorine belongs to group 7, it's a non-metal. And the charge on group 7 is -1. So it will have to gain one electron to become stable. So that's why we can say that to make an ionic bond such as NaCl, Na with Cl, we can say that the sodium has lost the electron, so it is oxidized, and the chlorine has gained the electron, so it is reduced, right? So now let's move on to the second part, the second example, which is 2 Mg plus O2, which will give us 2 MgO. So I would like you to please do this by yourself. I will give you the primary information. So magnesium belongs in group 2 and oxygen belongs in group 6. So I would like you to please pause the video and solve this for yourself and identify what you think is being oxidized and reduced in this reaction. Alright? Okay, so let me solve it. So I know that magnesium is a metal. So let me just label it right over here. And oxygen is a non-metal. So as a metal, it will have to lose electrons to become stable. And as a non-metal, oxygen will need to gain electrons to become stable. So I can say, because magnesium has a plus charge and oxygen has a minus charge, I will say that magnesium has been losing the electron and oxygen has gained the electron, because they are non-metals. Oxygen is a non-metal and magnesium is a metal. Okay, so let's label them now. Magnesium has been oxidized, so because it is losing electron. And this is gaining electron, making it reduced. Oxygen has been reduced and magnesium has been oxidized. So now we are done with the part 3 of redox reactions, which was in terms of electrons and gain of electrons. So now we are going to do the last part, the last point that defines what redox is, which is the increase in oxidation state and the decrease in oxidation state. So this is the most important one as well. So let's write it down. Right. So the most important question that arises when discussing this topic in particular is what exactly is meant by oxidation number. Oxidation number. You can call it oxidation state or oxidation number. It's entirely up to you. Both terms are completely correct. So oxidation number has a very limited active application as far as our syllabus is concerned. There are just a few things that you are required to know as far as this topic is concerned, because it has very limited application. So I will be going slightly out of syllabus, because going out of syllabus will allow you to do questions on redox really well, and also help you in constructing basic chemistry equations and also formulas as well. So there are a few points that I'm going to be writing of oxidation number to understand what's happening here. And once we have understood all those points, we will again be going back to equations like these and try to look at every single reaction with an eye for oxidation number. Okay, so the first thing or the first point is that the oxidation number of an element is always equal to 0. So what does this mean? This means that whenever you see an element in an equation, you just will put or give it or assign it a value of 0. For example, 2Na plus Cl2 gave us 2NaCl. So right now I have two elements I can see over here. Before I do this, what exactly, some of you might be thinking like, what exactly is an element? So an element is made up of only one type of atom. Notice how I'm using the word type. Not just one, but one type of an atom. Right, so I can see over here that there are two elements in this equation. So I'm just going to go ahead and give them and assign them the value of 0. Okay? Now sodium chloride will not be an element because it's made up of two different types of atom. It has Na and it has Cl as well. It does not contain not one but two different types of atoms, so it can be called a compound. Here you're bonded to two different types of atoms, so not an element. Okay, so now that that's clear, we'll move on to the previous equations that we've done. So let me just clean my color over here. So magnesium is an element, so I will write 0 over here, and oxygen is also an element, so I will write 0 over here over top of oxygen as well. Because magnesium oxide is not an element, it's made up of two different types of atoms, I will not be writing anything for now on this. Okay, so the first thing that you do whenever you see a reaction is where can I find the element. So when I find the element, I will first of all go ahead and put a 0 right on top of it, because I know the first rule of oxidation number, or the first type of rule that we did, is the oxidation number of an element is always equal to 0. Clear? So now let's move forward to the second point. So the second point states that the oxidation number of a compound overall is equals to 0. So now that we're done with the elements, we are now moving on to compounds. So now what does this mean is that the overall oxidation number of a compound is equals to 0. So when you talk about sodium chloride, the overall combined oxidation number is a 0. Similarly, magnesium oxide over here, the whole thing is going to be a 0. So this is something which will make sense a little more in a little while. Okay, so whenever we are dealing with a compound, its overall oxidation number is equals to 0. No matter the nature of the compound, it's a metal, it's a non-metal, it's covalently bonded, it's ionically bonded, it does not matter. So we are now done with the second point. So moving on to the third point. The third point is, in an ionic compound, let's make some space. In an ionic compound, the oxidation number of an individual ion individual ion is the charge of the ion identified by the number of electrons lost or gained. Lost or gained. Right. I would like you to read this one more time. So, in an ionic compound, the oxidation number of an individual ion is the charge of the ion, identified by the number of electrons lost or gained. So it basically means that you will identify the number of electrons lost or the number of electrons gained, and based on that we will figure out what the charge should be. So let's look at a few examples. Our first example is sodium chloride. So the valency of sodium chloride is that sodium belongs to group number 1, and chlorine belongs to group number 7. So sodium has a charge of +1 and chlorine has a charge of -1. So let's input those numbers over here, +1 and then -1. Is it safe to say that the overall charge or the overall oxidation number of this compound is 0, which satisfies our second rule? Yes, it is. So does it make sense now? So the charges get cancelled out in a compound. So I hope that's clear. Let's move on to the second example, Mg, magnesium oxide. So magnesium belongs to group number 2 and oxygen belongs to group number 6. Magnesium has a charge of +2, oxygen has a charge of -2. Let's input that over here, +2 and then -2. So I can safely say again that the overall charge or the overall oxidation number of this particular compound is 0, because so that satisfies our second rule as well. So now we are done with the two examples. So let's move on to another example. What if I have a transition metal? So a transition metal, let's go with iron 3 chloride. So I know that chlorine belongs to group number 7. So chlorine is going to be group 7. Iron is a transition metal, right? So I need to figure out that the charge on iron in order to make it neutral. So I know for a fact I can find charge of Cl, but I can't, because there's no group and no charge on a transition metal. I need to assign an unknown variable. Let's go with X, our most favorite, right? So let's go with X, and I know that the overall charge, the overall oxidation number of a compound is 0. So we need to construct a very, very, very basic mathematical equation, which I will go with X plus 3 times -1 is equals to 0. So X is minus 3 is equals to 0 and X is equals to plus 3. So the oxidation number of iron is plus 3. Let me just remove that over here. So chlorine was -1 and now iron is plus 3. Right. So this is very, 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 very simple. You just need to apply a very, very basic mathematical equation in order to figure out the charge. Right. So let's move on to another type of this question. So potassium magnate 7, just ignore the naming scheme, it's the name of this compound. Okay, so potassium belongs to group number 1, oxygen belongs to group number 6, and manganese is a transition metal. Okay, so I can just write down the charges, -2 and then +1, and write down x here as well. So let's form the equation, and the overall charge of this oxidation number of this compound is 0. So +1 plus x minus 2 times 4. Why times 4? Because there are 4 oxygen atoms. Likewise, I forgot to explain this earlier, that there are 3 chlorine atoms, which is why we multiplied it with 3. The charge of chlorine is -1, so that's why I multiplied it by 3, because there are 3 chlorine atoms present. As with this, there are 4 oxygen atoms present in here as well, so we will multiply -2 times 4. Okay, so this is equal to 0. So x plus 1 plus x minus 8 is equals to 0. -8 plus 1 is -7. X equals to -7. X minus 7 is equals to 0. So x is equals to plus 7. So when I'm writing oxidation numbers up top, I hope you noticed that I'm writing for a singular ion. Like, for example, in iron 3 chloride, I wrote -1 for chlorine. I didn't multiply with 3 and wrote down -3 up top. No, that's completely wrong. So I've written in the second equation, I wrote -2 for oxygen separately. Like, for example, I could have just multiplied -2 with 4 and told that it's -8, but that would have been completely wrong, because the charge on the ion I need is overall 0, and I need to write oxidation number for one ion only. So always write for a single ion. Always do it this way, because the simplest and error-free way, and always indicate at the end whether it's positive, because we in the basic maths we know that if a number is written, it's going to be inherently positive, right? But not in chemistry. We have to write a plus sign or a minus sign based on what oxidation number we get. Okay, so I have some homework questions for you all, which you will need to solve, and I will discuss these 3 questions in the next class, at the start of the next class. So our first question is K2 CR2 CR2O7. Number 2 question is Na3PO4, and number 3 is MgSO4. In this, the variables that we have, I will give you the charges. So potassium belongs to group number 1. We need to find chromium, so it's a question mark, and oxygen belongs to group number 6. Okay, so for sodium we have Na belongs to group number 1. We need to find phosphorus, so it's question mark, and oxygen belongs to group number 6. Let's write over here group number 6. And for the last question, we have Mg belongs to group number 2. We need to find sulfur, it's the question mark, and oxygen belongs to group number 6. So I will let's do a quick recap of this. You can take a screenshot right now, or you can just write them down as well. I hope that's clear. So now what we need to do is we need to do quick recap of what we have done in today's class. We have discussed how in terms of electrons, the loss and gain of electrons, how redox reactions work. We need to find out. We will need to first write the group and then label them as metal and non-metal, and we know that metals need to lose electrons and non-metals need to gain electrons. So based on the equation, we will then make arrows and distinguish which is being oxidized and which is being reduced. Always remember that the gain of electrons is reduction and the loss of electrons is oxidation. Moving on, we discussed for the first time oxidation numbers. So the number 1 rule was the oxidation number of an element is always equals to 0. So whenever you find an element in a reaction, always write 0 on top. to write down its oxidation number. As for a compound, the overall oxidation number of a compound overall is always equals to 0. And the third point, in an ionic compound, the oxidation number of an individual ion is the charge of the ion identified by the number of electrons lost or gained. So we did some few examples. We wrote down the group numbers and wrote down the charges and distinguished them as like they are 0. This is also 0, the overall charge, which satisfies our second rule of oxidation numbers. As for a third rule, we identified a variable and made it clear and wrote down a mathematical equation to solve for that charge of the iron in this equation. And in the last equation we did the same thing again. We wrote down the groups, we wrote down the charges, and then we solved for X to give us positive 7 for manganese. And now this is the homework for you guys. I hope you all understood today very clearly. So I'll see you guys tomorrow. As always, if you have any questions regarding this lecture, feel free to comment down below. Take care of yourselves. Bye bye.